let's do a little integration. The normal technique would be to use substitution here, and we would let u be 2x minus 1, and then we would take the derivative, perhaps isolate dx. Kind of depends on your habits. So I'll do it that way. And this integral will then become the integral of u to the negative 4. And dx is now d over negative 2. So pull that 1/2 to the front. And then we're going to add 1 to the exponent here and get negative 3. We'll divide by negative 3. So that's the power rule. And then we'll add a constant of integration. Let's simplify this a little bit. I'm going to put negative 1 in the numerator. Put a 6u cubed in the denominator, so getting rid of the negative exponent and moving the negative to the top or out in front. A couple of choices, your choice. And then we'll do a back substitution, and our final answer will look like this. Now that's a fair number of steps. And what I would like you to notice is that this substitution here is linear. And anytime we have a linear substitution, we can actually do this integration much more quickly using the reverse chain rule. So when we look at this linear quantity here, 2x minus 1, its derivative is 2. And normally when you take a derivative, you would multiply by the derivative of the inside function. Here, with reverse chain rule, what we're going to do is just take the 2x minus 1, add 1 to the exponent, divide by the new exponent, so that's the power rule part, and then divide by 2 also. So this quantity has a derivative of 2, and we, when integrating, divide by 2. If we were differentiating, we would multiply by 2. And so then our last step is to write this with no negative exponents. And here would be our final answer. And of course, it's the same as the other technique. And you can use substitution, but notice how, that wasn't a very good box. Just notice how many more steps substitution is, though. Substitution adds a whole bunch of extra steps, and you can just cut to the chase. Whenever your substitution is going to be linear, you can just do the reverse chain rule and divide by the derivative of the inner function.